Happy Wednesday, everyone. Hopefully, you guys are all doing well. Today, we'll be talking about 7-6. We're going to learn how to add and subtract polynomial. This is the first day we're going to be doing this, and we'll spend another day on adding and subtracting polynomial on Thursday. So go to your table of contents and then copy this down. Alright, let's start the notes. Again, the title is 7-6, adding and subtracting monomials day 1. Actually, not monomials. I meant to write polynomials. I'll cross this out really quick. So P-O-L-Y, polynomial. Down over here as well too. Polynomials. Today is the 15th. And the objective today is I will be able to add and subtract polynomials. So let me write that down really quick. So I will be able to add and subtract polynomials. So to start off, let's review really quick what like terms are. I know some of you don't remember this and know this already, but it's just a good refresher just so we can use this idea to help us add and subtract polynomials. So like terms are same variable raised to the same power. So same variable raised to the same power. So let me give you a few examples of like terms and non-like terms. So an example of like terms are like 4y and 7y, because same variable y and to the same power of 1. Another example would be like 8x squared and 2x squared, because they have the same variable raised to the same power. Let me give you another an example that is not like term. So something like 3x squared and 5x. They are not like term because even though they are the same variable, they do not have the same power. This one has a power of 2 and this one has a power of 1. Another example would be something like 4y and 7. Here we have a variable of y, and here we don't even have a variable, so automatically you can say that, oh yeah, they're not like term because they don't have the same variables. Alright, with that being said, let's move on to how to add and subtract monomials. There's 4 steps to do this. Alright, step 1, I want you to identify all the like terms. So identify all the like terms first. Step 2, I want you to rearrange the like terms so that all the like terms will be together and all the non-like terms will not be together. Step 3, combine like terms. So after you identify, after you rearrange, combine them together. And then lastly, the last step, write each polynomial in standard form. Alright, so let's try a few examples out. So I'll do the first one, have you guys try the second one, I'll do the third one, and have you try to do the fourth one. Alright, for the first example, we have 15m to the third power plus 6m to the second power plus 2m to the third power minus 5m to the second power plus 6. This seems like, oh man, it's so long and it looks like it's extremely hard, but it's not too bad. So step 1, you want to identify the like terms. Again, same variable, same power. So I'm going to start with this 15m to the third power. I'm going to put a square around this. And then keep on going. When I find another m to the third power, I'm going to put a square around that one. Nope, this one has a square. Oh look, this one has a third power. So I'm going to put a square around this one. Keep on going. Oh no, this has a square, and this don't even have a variable. So we're done. Let's go to the next one. So 6m to the second power, I'm going to put a triangle around this one. And then keep on going and see if I find another m square. Oh, here's another one. Let me put a triangle around this one as well. And then lastly, this one is alone, so we can leave it alone. Step 2 is to rearrange all the like terms. So I'm going to bring all the 15m squared together, all the m squared together. So let me rearrange and write that out. So as you can see, my m to the third power together, my m to the second power is together, and my 6 is by itself. Step number 3. Now we can combine the like terms. So 15m cubed, or to the third power, plus 2m to the third power will give us 17m to the third power. 6m to the second power, take away 5m to the second power will give us plus 1m to the second power. And the 6 has nothing to combine with. We are done. This is our answer in standard form. Alright, so let me give you one to try on your own. So try number 2 on your own. So pause the video, take a minute to try this out, and then come back and check your answers with mine. Alright, so welcome back. So let's do this together. 3x to the second power. I'm going to circle that. And then keep on going to see if I can find another one with the second power. No, this one don't have x to the second power. Oh look, this one has an x to the second power. Let me circle that one out. Let's keep on going. This one don't have x to the second power. This one has an x, but not to the second power, so I can't circle that one. Alright, let's keep on going. So I'm gonna put a square around this 5. And then look, oh, there's another one with a constant number. And looks like that's all we have. So step 2, rearrange the like term. So I'm going to rearrange all the x squared together. So 3x squared minus 7x squared. And then I'm going to put all the constant together. Plus 5 plus 12. And then last but not least, that lonely minus 7x by itself. So if we're to combine this, we will get 3x squared take away 7x squared will give us a negative 4x squared. 5 plus 12 will give us positive 17. And then lastly, the minus 7x will be by itself down here. Currently, right now, it is not in standard form, but that's okay because I didn't ask you to put it into standard form. I just asked you to add or subtract this. If I was to ask you to put it in standard form, you should, but right now, you can leave it like this. Alright, let's try a few more. I'll do example 3, and then I'll have you guys try example 4. Alright, example 3, so 2x squared times y minus x minus 5x squared times y plus 3x minus 1. So this one may seem like, oh, it looks extremely long, looks really complicated, but it's actually not. Think about this, all the 4 steps that we learned a little bit ago. Just apply those, and I think you'll be fine. So if we look at this, we have a x squared y. I'm going to box that. Keep on going and see if we have another x squared y. Nope, just an x. Oh, here's another x squared y. I'm going to box this up. X squared y. And if I was to continue, oh no, no more x squared y. So let's continue on. We have a x right here. So I'm going to circle this. And we keep on going. Oh, here's another x. I'm going to circle that. And then we have this lonely 1 by itself over there. So that's okay. So let's rearrange this. All the x square y by itself. 5x squared y. And then all the x by itself. Minus x plus 3x. And then that lonely 1 at the end. After that, we can combine like terms. So 2x squared y minus 5x squared y will give us a negative 3x squared y. Negative x meaning there's a 1 in front of it. So negative 1 plus 3x will give us a positive 2x. And then the lonely 1 will come at the end. So you're done. This is your answer right here. As you can see, we don't have any other like terms to combine, so you know you're done. Alright, try the next one by yourself. Alright, so try example 4 on your own. So 9x squared, take away xz, plus 6xz minus 15x squared. So pause the video, try it out, and then come back and check your answer with mine. Alright, welcome back. Hopefully you give that a shot. So let's start with the 9x squared. I'm going to circle this one here. 9x squared. Let's keep on going. Let's see if we have another x squared. We have an x right here, but not a square. 6xz. No. Oh, here's one right here. So let's circle that. Negative 15x squared. Alright, let's keep on going. We have a negative xz. I'm going to put a triangle around that. You can choose whatever shape you like. I just choose this one because I think it's easier to draw in here. And then here's another xz. Alright, let's rearrange these. Let's put the x squared together. 15x squared. And then let's put the xz together. So minus xz plus 6xz. If we're to combine these like term, 9x squared minus 15x squared will give us a negative 6x squared. And 1xz plus negative 1xz plus 6xz will give us a positive 5xz. So as you look at this, we don't have any more like term to combine, and this is your answers, and you're done. Alright, so hopefully by now you have an idea of how to add or subtract simple polynomials. We'll continue this again tomorrow when I come back to school. So bring any questions you have tomorrow so I can help you clarify anything that you don't understand. Again, have a great day, and I'll see you guys tomorrow.